Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by Techstrong and Legit Security. My name is Cody J. Brown. I'm the host of Techstrong Learning. We have an exciting presentation ahead, but first I have just a couple of housekeeping notes to cover. First, today's session is being recorded, so if you missed any of our discussion or you'd like to rewatch or share with a friend, the on-demand recording will be made available shortly after we conclude our live webinar today. If you have any questions, we want you to send those into the Q&A tab on the right side of the screen. We're going to address all of those live towards the end, so be sure to send those in throughout so we make sure to leave enough time to answer them all. If you have any thoughts about today's webinar, we want you to send those in using the chat tab. We want you to engage with the rest of the audience. Let us know your thoughts on what we're talking about. And finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around till the very end. So our topic is the hidden software supply chain risks that can ruin your 2022. And joining me is Liav Caspi, CTO and co-founder of Legit Security, and Alex Babar, software supply chain security advocate at Legit Security. Thank you both so much for being here with me. I'm going to turn the program over to you.
Thanks, Cody, for that introduction. With that, let's go ahead and get started. To start today, I put together a little icebreaker for everyone on a game called There's a New Software Supply Chain Attack. Big surprise. The goal is you need to assess your risk. Your software supply chain was attacked. Your board just called the CISO into their office, in the board meeting and said, hey, what's our risk exposure? Thinking it's a pretty simple questions. CISO talks to the application security team. They're trying to scramble to understand, hey, what is this attack and are we compromised? So the details of the attack are that it is a Bitbucket companies using Bitbucket are vulnerable. It's a source code management system, a popular one. And so first order of business is to find out if your company uses Bitbucket. So to do that, I want you to look at the word search jungle that represents your tech stack maze and find Bitbucket. I'll give you 5 seconds because that's plenty of time to do it. All right, now that 5 seconds are up and you found Bitbucket, we don't just want to find that. Turns out you're a cloud native shop, and you also want to have eyes on the build server that plugs into it, the relevant build server. So go ahead and also find Jenkins. That should be just as easy. So I'll give you 5 more seconds. All right, great. So now you've found the SDLC assets. You kind of know, how if you need to care about this attack or not. Turns out you are. So you now want to actually look for the vulnerability in those assets. So last one, again, super easy. 5 seconds, find vulnerability in the word search. Okay, cool. I actually won't believe anyone that completed this game successfully in the allotted amount of time. I think I made it too hard. I hope that I did. But let's do an easier one. So with this as your software supply chain and the visibility you have into it, same game, just try and find Bitbucket. I'm not even going to bother with the countdown. You probably found it already. Find Jenkins. Again, probably found it already. And now let's actually find that vulnerability. All right, cool. So I'm sure you're done. I'd actually believe anyone that told me they solved this one in the allotted time. And really the point is that it shouldn't be that hard to find these things when they happen, but it really is for a variety of reasons that we'll talk about today. This stuff is really hiding in your software supply chains. With that in mind, thanks for playing. Let's move on to intro. So I'm Alex Babar at Legit Security. With me here today is Liav Caspi, the co-founder and CTO. He's going to talk to you today, bring you an industry veteran point of view on the hidden risks in your software supply chains. Going to kind of describe what that means and kind of walk you through the agenda here to kick things off. And then, we'll get into the meat of the material later on. With that, Liav, why don't you take it over?
Sure. So thanks, Alex. And thank you all for joining. So I think the agenda for today is going to be made of mainly 3 parts. So the first one is just to define what does it mean software supply chain attack surface, there's been a lot of vendors and a lot of talk and about software supply chain and a lot of attacks. So we're going to try to look at all the incidents that happen and what the industry is defining as software supply chain security. And then we're going to review some of the risks that are part of software supply chain security based on, we'll use 3 use cases and drill down that are all based on events that happened in the last year. And then just time for Q&A. So I think we can get started. In the last 3 to 3.5 years, according to this timeline, there's been a huge increase in the number of breaches that were categorized as software supply chain attacks. This slide only names the major ones, but there has been a lot more happening to this point. So what's the definition of a software supply chain incident or attack? So I like to think about it as in terms, and this is what we do here as well in legit security, is the concept of a software factory. Meaning every organization has an operation going on that eventually produces software, or either to sell to someone or just to deploy to their cloud to provide a service. When you think about all the systems and people, identities, processes, scripts, all these moving parts that are used to build up and create software in an organization, you could somehow put a circle around that and say that's the code factory. And when this operation is breached, there are mainly two bad things that can happen. One is somebody can influence the output software, whether you could either distribute something malicious like happened in SolarWinds or CodeCov, or you could upload a service that's now doing something malicious to the customer that consume it as a service. For example, Kaseya, that was a backdoor. So there are a lot of places, and we'll see it through this webinar, to infiltrate or attack this development factory. And the second bad thing is that somebody could steal data from it. So some of the incidents here are just code that was stolen or passwords that were stolen from development assets. And code is a very precious asset in an organization. It's sometimes in a software driven business, it's the most collaborated upon asset, more than documents. And it has the blueprints of the application. It has secrets and passwords that are used to communicate between the different services that are deployed. So some of the attacks started with attacking some development infrastructure, getting some information from that, and with this information creating a bigger breach. So I think it's important to just talk a little bit about why is this happening now? Why do we see this congestion of red dots around the last years? So nobody thinks there is one factor, but there are a couple of trends. I think that there has been a huge change in the way software is developed around the world. A lot of organizations are moving their development style, basically. It's no longer the term here on the slide, on-premise development, means you are developing something that you work internally on, building an app, doing all the tests and releasing it, to a more distributed, live and dynamic cloud development. If you think about it, most of the software today is kind of in a trend to become software as a service. A lot of organizations are developing web application or providing APIs and providing services over the internet, and this is mostly associated with cloud. It's not all these use cases, but most of them. And most of the businesses transform their development operation to a CI/CD. They use multiple open source libraries and images and third parties. Their software is distributed. It's made of multiple microservices. I think Amazon once attested that they have something like, I don't remember the number, but like 10,000 changes in their production environment every day, which is a huge number. But if you think about, a bank today or a small organization, there is a good chance they're still doing thousands or even hundreds of changes to their production environment daily. So this is a very big change. And the development practices changed from that purpose. So things are more automated. Developers now collaborate from all around the world, where once you sat next to somebody to do code review, today somebody from the other side of the world is giving you comments on GitHub on a project you work together. The workforce is distributed. The code build chain became made of multiple systems. So all of these trends together are combining to a huge attack surface. So there are multiple ways in which anybody could attack a development environment, because there are a lot of people, a lot of systems, a lot of third parties. And usually, development teams want to run and work fast, and they don't want to, approve any new integration they do, any new plugin they add, any new package they're using. So the attack surface is huge. And basically, if you look at a lot of the attacks, it's just mistakes. So you could do 3,000 changes or 3,000 operations in GitHub, and all of them would be really good. But then, there's just one that could be devastating. There is an example here. I think we witnessed one of our customers had an incident where an honest mistake took one of the repositories public, and combined with another mistake they made, they put a lot of passwords there, which they removed, but they didn't know were still in there because they were part of the Git history. And this thing was public for some time. They were alerted about this, but it was a little bit too late. Created a huge incident in the organization. They needed to revoke everything. They needed to take it as private, erase some of the data, because it's some of the data was not just passwords that you could just revoke, but also sensitive customer information they didn't want that anybody could copy. So they had to really remove it from Git history. And if somebody attempted this in the audience, it's very hard. Another example of a mistake I witnessed a couple of years ago was some DevOps engineer that I knew, just by a super honest mistake, made a Jenkins server public. And this Jenkins server had the very cool feature of having a free registration. So anybody on the internet could just register, create a user, and then start running jobs. So the next day, the server was mining a lot of cryptocurrency and eating up a lot of cash on AWS credits. So it's a mistake, and these mistakes could happen when you have such a large and chaotic environment where everybody's doing a lot of things, and they're trying to work as fast as they can, combine a lot of pieces together. So again, getting back to the same point, there is a huge, seems to be a new attack surface that's starting to worry a lot of the organization and getting the attention of hackers and malicious actors. So from that, we'll move on to define what's like the software supply chain that we mean, what a software supply chain looks like. Just before that, maybe another point that's we started to hear a lot in recent times is that, first of all, there is a lot of predictions that are not very happy about, the rise of this type of attacks. So Gartner predicts 45% of organizations are going to be experiencing some attacking on their software development infrastructure through a malicious component or directly. So that's in the next years till 2025. So that's a big number. And like organization up until today that suffered such attacks had, billions of dollars in losses. And the last point, I think, with nationwide conflicts rising in the world, it is very likely that nations with cybersecurity capabilities are using their software or using software, to infiltrate, or as kind of like as a weapon or as a way to spy. So it's a very a lot of intelligence companies or threat intel are seeing a big rise in talks about tampering with software in order to get this multiplier effect, infecting a lot of systems. And there is a lot of fear, especially if you're government or regulated industry, or that you're a target by some nation state. So this entire topic is very a big concern to the software development community as a whole. And it's no longer required today to sneak microphones into chairs. If you could simply put a flaw in some software that's going to every phone, for example, and then have a backdoor to get everything you want. So this is a very, very simplified model of how a build operation looks like, or a software development operation looks like. A developer at the end, source code management system, build tools, someplace where you store what you built, like an artifact registry. During the build or during the building of the software, dependencies are being used. These are third parties. I'll describe type of dependencies, and eventually the produced software reaches a customer, but you could switch that with deployment to your production environment, so to the cloud. It's very, very simplified. For example, a model that's been used by OSSF in the Linux Foundation that's called SLSA, SLSA, is describing the model almost like this, and points the different attack vectors on every line and every system. So if we encircle that, we can say that we're going to follow the industry definition of how do you secure that. So how do you secure this or the pipeline? Traditional application security, like static analysis, or tools that use dynamic analysis, or looking at infrastructure as code, they are concerned with removing vulnerabilities from the logic within the code. The security of this environment is more around the infrastructure level. So another way of putting it, let's secure the pipeline itself rather than its content. So that's where industry like NIST and other organizations are trying to define what software supply chain security is how am I, as a software organization, can lock down this environment and prevent anything bad happening from that, either information exposure or tampering. We can distinguish between two types, like internal software supply chain attack, meaning what happened to SolarWinds as a company in the SolarWinds incident, meaning the organization was compromised and it produced malicious software. And also you could look at external attack, meaning you are a consumer of software and you were influenced by some malicious component. So I think both threats are something you want to protect against. And we're going to touch both of them, both on the consumer side and on the producer side. And sometimes these things are chained, because you get a library that was infected, so they suffered an internal attack, but then it got included in some software that was then later distributed to someone. So it's kind of like software introduced in another software in another software. So this things sometimes chain up to a larger influence.
Hey, Leo, and I think that's a really good point. I definitely want to call attention to, because traditionally in cybersecurity, I know there's hey, I'm too small to to be an attack, to be a lucrative attack worth time. But what's kind of changed, and you saw this with SolarWinds, is I might be small, but if I partner or have customers that are large and attractive, then now all of a sudden I'm being attacked, not to cause problems necessarily to myself directly, but just because I'm a conduit to something else that they want. And this interconnectedness, I think, is one of the things that makes this software supply chain attack just pattern holistically, pretty volatile to the industry. So I've heard this phrase from other cybersecurity leaders that we're a team, we're a village. And so I'm kind of building this next generation of software. I think it is definitely worth mentioning that it's also not how can I stop the attack for my own internal pipelines, but also to prevent that from moving on to someone else as well.
Yeah, I agree. Thanks. Maybe just to capture some example, I'll show you how it looks on some of our platform. But for example, so this is a screen from legit product, and this is an example of a service stack that's actually building software. So you have GitHub COM as a source code management, and then use this CI uses as artifact registry, and then deploy to Amazon. And our stack here uses we'll move here, uses Azure DevOps in the cloud, Jenkins, and JFrog. There is something I'll talk about later. You can see here things that are kind of like discovered. Sometimes pieces and systems and services used to build the code are sometimes not known to the organization, and a lot of the times that an attack is happening, it's because something was neglected, or kind of like the old concept of shadow IT. So sometimes we see this happening as well. So with that, I think we'll move to look at some risks and specific use cases. And we're trying to talk through what are the models that are offered today to secure them. So today we're going to focus on 3 major use cases, and I'll show some examples between for every one of them, and sort of a checklist of the most important things that we see organizations take today, and also help them as a vendor to go the journey for securing their environment. I'll also mention there is also a benefit, not just to lock down your environment and prevent somebody stealing things from it or attacking it, but also to drive a more mature SDLC in a secure process where things are more stable and vulnerability free. So it also helps to create a very secure software development lifecycle as a whole. So we're going to look at submitting malicious code. So somebody who's going to use the system to just introduce code that's wasn't meant to be there, and doing malicious things. We're going to look at how to secure your development tools, like the build system and the artifact registries that could be also infiltrated. Best example is SolarWinds, where a build server was compromised to tamper with the build process. And we'll also talk about attacking through dependencies. This is actually what people think about when they think software supply chain. They think about, well, dependencies could be used to compromise my software. But we'll see here that in most of the cases, well, yeah, some dependency got compromised, but then there are a lot of examples where systems and processes were compromised rather than specifically a dependency. So open source dependencies is just one piece of the problem. 3 layers or 3 themes go along the way. So there's, you want to secure the configuration, you want to do strong authentication, and you want to do verification of things. So you want to make sure that processes are verified. I'll show how they are, but I'll just mention that as we speak today, and it's a topic for another webinar, a lot of frameworks are being drafted. So an executive order by the White House after SolarWinds started the creation of multiple frameworks that talk about how to trust software. Organization that, for example, the OSSF is working on multiple projects actually to increase the security of software around the world, from reputation into scoring into verifying dependencies. So multiple things are underway as we speak, because again, this is more than even a one organization problem. It's a community problem, and it's a problem in the world. So in the broader sense, how can you trust software? So look at the first attack vector of somebody trying to submit malicious source code. And if you think about how could you defend against something like that, and actually, Alex, I think there was some news really recently about Twitter. I'm concerned about that.
Yeah. So TechCrunch published maybe a couple of weeks ago, amongst all the buzz of Elon Musk making his bid, that they were doing a code freeze and they were implementing code reviews that required VP level and above. So I kind of took that as a reminder. A lot of this, I think, at least I personally have this tendency to think of the threats coming from outside the building, but submitting malicious code could happen from everywhere. So in this particular case, they thought employees would be disgruntled. They didn't want to take any chances on malicious code being submitted. So they're implementing code reviews at a kind of executive level to actually sign off, which I thought was quite interesting, given the nature of where we're looking and defending against Leo.
Yeah. Cool. So so it's starting to be concerning to a lot of organization, and so to kind of like, if you think about what you're going to do to prevent this thing, I'll show you some example. So these are the most important things that organizations tend to do that. So first, do strong authentication, meaning everybody should authenticate, and preferably with least privilege. Sometimes it's hard, but try to remove as many excessive privileges as possible, specifically for admins. One thing I'll mention about what's written here is the importance of named access. So we've seen a lot of organizations where code is public for the internal organization. So they say, well, everybody could just access the code. It's an internal, let's say, GitLab. What's problematic about it is that anybody can access the code and even secrets without any named access. So when there's going to be an incident, audit logs or anything would never tell you who accessed the server, when, and how. So actually, you've seen a lot of organizations that used to work public with all the code public to the entire organization, locking down and doing named authentication on everything. I think the second thing is something I can't overstate how important it is. Almost every code collaboration platform supports change management and supports either branch protection or code review, merge request, pull request, different names, but they're all saying the same thing. Nobody can introduce a change to the code that would eventually go through the pipeline and be built without another approval. This usually prevents most of the attack on open source software, because you need to gain the trust of the maintainer. You can't just introduce software and there is another person who needs to approve that. So that's actually prevents a lot of the things. Usually with Legit, we sometimes saw this complex attack vector where you have a developer that has low authentication, that has access to a sensitive repository that has a complete, deployment to the cloud and no controls over that. So you could just, a contractor that still has access to the code could introduce a change, and this change would automatically go to production without anybody even looking at it. Then I'll say it before, there are more things than open source libraries. So recently you've seen an incident where GitHub OAuth tokens were stolen to access client data. So this just happened because there was a plugin or an app that had access to the source code. So the attacker could leverage that, and part of the attack surface is just understanding what access did you give to the source code or to any other system here through third parties. If you let the development team roam in GitHub, you'll find out probably tens or dozens of integrations that are going on there that are accessing the code, scanning it. Some of them are for good purpose, but just the idea just to control them and make sure some of them are still in use, some of them are not, are trusted vendors. This is a very good place to start with, just to understand that you're not missing out on something. And then alert and insecure activity. For example, somebody has rights to bypass the code review, and if they invoke those rights and forcibly push something without change, like admin usually can do this without review, you want to catch that. There are controls on almost every development system that you could turn on to see that. I can show a few examples on the Legit platform. Let me switch to that. So there are a lot of authentication controls you can turn on. It's simply just getting the right switches on, or tracking, for example, two-factor authentication, even for external collaborators. And these are policies that our platform can validate. We've seen users with personal email, for example. This happens a lot. And then, when the person leaves the organization, sometimes they still have access. Another thing that we can see are, well, I have here example of incidents, but like apart from code being public, anomalous activities like admin access token created, external collaborator given permission to a sensitive repositories. There are audit logs in all the systems, and it's easy to get the important risky event first. So the bigger the organization is, and we've seen a lot of big enterprises and organizations that have multiple development team, overseas contractors, sometimes in the thousands, just mapping out these and getting them, and they don't happen a lot, and getting a secure and a very secure process for authentication is a very good key step. And as well, getting a review turned on every repository. So I'll move on to the second example, which I think is interesting as well. It talks about attacking Devtools pipelines and infrastructure. So there are multiple systems used to build and store artifacts. Good examples are Jenkins, JFrog Artifactory, Nexus Artifactory. GitLab has in itself a CI, and all the major, Atlassian, Bitbucket, also provide these capabilities. So those systems are where things are being built, they're being stored before deployment, and the same thing here applies. So, for example, again, having through authentication, securing the access of them. So we've seen an event where an artifact registry was public on the internet with a CVE. So anybody could just get in and swap the artifacts that are there. So making sure they are secure. I'll mention another 2 points that I think are interesting. Second one is not everyone thinks about it at this point, but you could very simply introduce verification in the build and the artifact process. So when you build something, you could sign it. So there are signing tools available and signing projects, and we also can help with that. But getting a signing step for important artifact could be useful just to validate its signature, so you know that nobody changed it on the way, and also just to verify a checksum. So you could take a checksum after a build happens and then verify it when you store it, or verify before you deploy. So there are multiple examples of this, and doing some verification in the build process strongly reduces the risk of something happening. You could do this end to end, from the source code, signing the commits, and then making sure everything is signed. This is sometimes, a bit an overkill for an organization, and we didn't see a lot of organizations do this today or implement it to the full extent. But having just an artifact signed is a first step. In fact, the new standards that I mentioned before talk about having some kind of a provenance or a signature as part of the artifact that could attest that it's authentic and was signed by some kind of a signing service. So it's something you should track, and Legit, as well as other vendors, would provide these capabilities of verifying artifacts. And this seems to be the direction where software verification is going, in terms of making sure it was not tampered. Third thing as well, there are a lot of scanners and third parties that are running inside your build. Sometimes it's even security tools. And there was an incident, I think a couple of years ago, where a security tool was used to steal source code from customers. So you should be in control, again, of your attack surface. I want to show you an example, which would also be part of the third parties examples, but I'll show it here, that we've seen in many organizations, that talks about what are you using in the build and how do you make sure it's safe. So in this example I'm showing here, there is an external resource that's used without verification, meaning there is a pattern that somebody downloads something from the internet, executes it immediately after without any verification. So you're completely in the mercy of this component. So I think I have here like a code call line where you're doing some kind of a download command and then immediate execution. This pattern is an attack surface by itself. And the remediation is pretty simple. You just need to just verify the checksum of this thing if it doesn't change, or just statically use the version. Well, sometimes if you completely trust this binary and you want to get the latest version every time, you should use it. But all the best practices say that the default should be just verify what you do. Here is another example of wget something and then immediately bash. So that's just one example of how you could have like a supply chain attack surface within your build tools, very simple without even knowing it. So I'll move to the third example. That's the dependencies example. And here I just want to stress that the most important thing is that you understand what are all the dependencies that are part of your build. It's not that easy. And the attack pattern is a dependency you're using is malicious. So actually, traditionally, there is an industry today called SCA, or open source security, with a number of tools that can tell you what vulnerabilities you have in open source component. So vulnerabilities would affect your application. And what we're trying to hunt here is whether a dependency is going to do malicious thing either during the build or going to affect also, for example, steal your code or do something inside your pipeline. And I think the concern here is when a vulnerability is found, like, for example, log4shell, it's already after the fact. We're already in incident management crisis. What organizations are trying to do is to proactively make smarter decisions and reduce the attack surface. So another example, so there are a lot of third parties, not just open source. There are base images, there are executables, just like I showed you now, open source libraries, plugins that we talked about before. So in order to reduce the attack surface from these, it's important to use them safely. So the configuration of the package manager and the way you're consuming them is important. So I've shown you one example of, don't run something without verifying it. Another example of this would be, don't use the latest version of something. So for example, you have here, so this is an Amazon image, so it might be good, but when you're building off a latest image, you are linking to something dynamic that might change. So imagine that someone from the other side of the world, might be even a kid, comes back from high school and pushes new version, and that version automatically goes into your production. And if you think about this situation, it's absurd. So if you completely trust the vendor, like if it's Microsoft, Amazon, you might say, I want to get the latest updates and the latest security updates. But if this is some software you only use yourself, you might want to consider using the latest and removing this attack surface and focusing on on a specific known version that you know. Although also tags can have their own problems and might change, but that's a lower risk. Another thing that I put there is write safe build scripts, and I'll show an example here. That's like a command injection, very simple one in a GitHub action flow. But there is a way to get information or get control of the pipeline, not through the content of the library itself, but through flaws in the pipeline script. There are a lot of security advisories on writing safe pipeline scripts. In this example, there is a line in this pipeline script that executes input from a specific step. So for example, this one is looking for the pull request body. So it means that I could submit a change request and immediately execute code in the pipeline and actually, send myself some of the passwords that are stored in the repository secret store or do things. So there was a notion that was dubbed PON request, where some contributor could just submit a code review. And then with that submission, test pipeline that was used just to test the code actually ran malicious commands. So it's actually by submitting code, they could execute malicious commands in the pipeline and change things or get data. We've seen attempts of that. There are a lot of publications about what to do it, and some tools like Legit that could do security linting on the build script that are being written and remove these vulnerabilities. So I just want to mention two more important things. So first, maturity and reputation should be part of the choice. So OpenSSF and other organizations are doing a lot of work to get reputation scores and maturity into libraries. So when you choose an open source library, which is non-standard, it should be in the developer mindset as well to make sure, like, how many stars does it have? Who is the developer? And we got requests as a vendor from enterprise organizations to assess the developers that contributed code, whether they have ties to a state they assume is hostile to them, is trying to attack them, and might use them to change the code. So there are some statistics in GitHub you could use or for open source. And there are a lot of things like scoring and scorecard and maturity. And you can, if you go to the OpenSSF website, you could look at various projects and dashboards that are giving scores and can give you some insights on a reputation of a specific library. And then scan your dependencies as well. There are scanners, as I said, even some of them are coming with the infrastructure you have that could tell you whether a dependency is already compromised or has a specific vulnerability. But going through this list and mapping out your attack surface is, I think, the first step to deal with it. I just want to sum up, and then afterwards we'll leave room for questions. So we talked about software supply chain security, which means we look at our development factory and want to lock it down and make sure the software that is being produced there is safe. So a common theme around what we did so far in this presentation is kind of like a zero trust concept. It means you need to map out your attack surface and then validate things and make sure that, first of all, you don't assume that things are safe. Don't use the latest version of something, or don't just assume that things you download off the internet are going to be safe. And also just map the attack surface. Understand what permission you gave where, and put the maximum controls you can. There is no, unfortunately, like one solution to that. There are multiple configurations that need to be set and multiple systems that need to be tackled. So, and when we see organizations trying to lock down their environment, I think the two key things that we see is that first, the first thing is just to understand what you have. So you map out what you have, what's the inventory of things you want to protect. And the second thing is to implement this incrementally. So you go with the little things you can do and improve the maturity of things from, securing the authentication and access, and then going on making sure all dependencies are scanned, and then going to another level, which means doing verification on the software that is created. So you could just tackle it by steps until you reach a very good level of hygiene and security. And again, going back to the one mistake in 3,000, you cannot overestimate the value of good hygiene. So I think with that, I'll give Alex to say the last words.
Cool. Thanks, Liev. Thanks for that presentation. Hope everyone enjoyed it. Just to add to what Liev was saying, I think it's also worth mentioning that it's the development team that's that's running these pipelines and putting these things together. So it's a needle in a haystack problem sometimes, finding these vulnerabilities. But someone else is messing with the haystack and the needles. So security needs some sort of way to understand that and understand it more quickly. Folks are going through Log4j. I have, colleagues and friends in the software business that, part of the problem is just finding out the right people to talk to that know what the right thing is. And then there's always this question of, well, I guess it's on the honor system that we've got it all. So again, when we kind of think about how interconnected and integral software is today, it really gets me motivated to keep trying to solve problems in this space. And with that, for folks out there that are interested in more content in software supply chain security, DevSecOps, and the like, definitely visit our website, legitsecurity.com. Check out our blogs and resources. And for those of you that might have been curious when Liev was showing some of those product interfaces, the intent today was not to do a product demo for you all. It's a new concept. And, and getting feedback from some certain folks, what I kept getting is it was hard to visualize what a software supply chain looks like. And some of these risks and attacks. So that's why I want to kind of show it in a tangible way for everybody, but it was more meant to be illustrative. If you visit our site and want to learn more, you could book a demo with us anytime. Definitely feel free to do that. On that note, let's go ahead and wrap up and move it to Q&A.
All right, so I'm looking through our questions, and the first one reads, how would you recommend prioritizing risks that exist in different parts of the DevOps pipeline?
Yeah, so I'll just tackle that for now. Liev could obviously provide a better, more thorough response than I can, but I could share what we've seen on how, our customers prioritize the different issues in the different parts. So just actually, Liev, you're on? All right, I guess not. Just interrupt me, Liev, if you connect your mic. All I was gonna say is how many of our customers are prioritizing it's context. Context is what matters and kind of helps surface which issues have the most risk and surface that to like the forefront of their backlogs. That context is based typically on like two dimensions from what I've seen. It's the compliance mandates that they currently have. Some of these issues with software supply chain security are increasingly correlating and relating to known frameworks. And so, you have folks that want to be SOC 2 compliant, for example. There's a particular, issue with allowing developers to access systems without multi-factor authentication. So there's a relationship there. So oftentimes they will prioritize the issues surfaced in software supply chains that put them out of compliance. That drives urgency in their organizations. The other is just, kind of how mission critical is the pipeline itself. You have kind of like sandbox pipelines and development, environments, and you have kind of the mission critical bread and butter of what companies are developing. And so typically as issues surface in those critical pipelines, that also creates a lot of urgency. And those are the two dimensions that I've seen a lot of. Yeah, so with that,
Yeah.
Oh, there you go, Leo. All right, why don't we hand over to Leo, see what I missed?
Yeah.
Can you hear us?
Yeah, I don't know if you can hear me. I had a slight problem here with the internet. So if you can hear me, I just want to emphasize what Alex said and say that defining what the most critical business apps, that's one of the first basic steps to go. So you need to understand what is the app that's customer facing or providing most of the critical functionality of your organization. And that should be the first focus.
All right. So our next question reads, you mentioned that open source software isn't the be-all, end-all of supply chain issues. Can you elaborate more on risks outside of just open source?
Yeah. So I'll start. Alex, please feel free to just continue and say what your thoughts are. So open source software is just what makes your app, is part of the layers of your app is your custom code and your open source software. But part of it is also images that make up your containers, plugins that build your code and use to compile it, the infrastructure like Jenkins, the plugins that connect it to your Jenkins and help you compile it. So if you think about how many vendors do you have that are involved in building and deploying your code, you'll end up, finding the more cloud native and CI/CD you go, you'll find things like Terraform, and you'll find things like CD applications, and you'll find a lot of, marketplace plugins that you plug into your system, secret managers, and others that are exposed to a lot of the content and the code, but are not necessarily open source. Just to bucket them in categories, I would say open source libraries obviously is one, but the other ones I would say apps and plugins that are part of your infrastructure. So any GitHub app or GitHub plugin that you use, that's the second category. And the third one I would say is everything around your container images. So, and your pipeline scripts. So any extensions to your scripts, or if you use GitHub Actions, you'll know it. And any base image you base your containers on.
All right. And so the last question that I'm seeing right now reads, can you elaborate on when or why the use of mutable image risks should have me concerned?
Well, nice. Yeah, so mutable image means the image can change on the other side. It's not fixed. So we had a concept of a golden image, pretty known ID concept, for years. And a golden image might, sometimes you might discover something with it, but it doesn't change. Every time you build on top of it, it's the same image. Mutable image means you're compiling with the latest version of something. And now the latest version, it's not a specific version. What is the latest? Tomorrow it's going to be different. So if you're kind of like creating a door in your pipeline to some other vendor to just say you just trust them to bring your latest version, and that's the opposite of zero trust. So if you need to really think first, do you trust this vendor? And if not, you should go to a specific version or to a specific image that you store locally and use. And maybe reiterating points that were said before, you really need to figure out what are your trust points. There are a lot of places you should go zero trust and not use the latest or mutable links. And you should definitely have a list of the things that you decided deliberately to trust. Like some people that we know, or some customers say, we want to trust Microsoft Image. We want to use the latest because we trust them to fix security vulnerabilities. But if it's a different vendor or someone you don't completely 100% trust, it's strongly recommended to pin to a specific version that won't change time over time.
Just in closing, as I mentioned before, for more content on software supply chain security, check out legitsecurity.com. And thanks for watching.
Awesome. Well, to Liev and Alex, thank you both for being here with us today. For our audience, the session was recorded. So following this panel, you'll receive an email with a link to access the on-demand. You can also find the recording living on the Security Boulevard website. Just visit securityboulevard.com/webinars and be sure to look in the on-demand section. So we do have those 4 $25 Amazon gift cards to give away. Our first winner is Mike G. Our second winner is Maria M. Our third winner is Charles S. And our fourth and final winner is Mustafa S. So to the 4 of you, congratulations. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. I'd like to thank Legit Security for sponsoring today's webinar. And my final thanks before we close out is to you, our audience. Thank you so much for being here with us. We ask for one extra moment to fill out a brief post-webinar survey, but otherwise we hope to see you at an upcoming Techstrong Learning webinar. Everyone have a great rest of your day. And again, Liev and Alex, thank you so much.